And I would like to invite her for her speech. With applause.
Thank you, Prof, for a nice presentation first. Let me start my presentation. After my PhD, actually, I focused on the security part of software-defined network because my PhD thesis related about software-defined networks and load balancing issues. And after my PhD, according to 5G and beyond requirements, the security is an important part. And the blockchain secure software-defined network is also a hot topic issue in this networking area. And now I'm in software engineering department of Manisa Celal Bayar University, and my PhD was from Istanbul Technical University. Today we will consider the blockchain secured software-defined network, and you can see the details in my just published paper in pervasive and mobile computing. I have general concepts today, but the details can be found at there. And blockchain, the main idea of blockchain is being distributed way, actually. We trust the computational work in distribution. And in SDN, the main idea is being centralized view. We have global view in order to optimize the whole strategy during the network and also continue with the load balancing issue, any network strategies, all challenges. Today we will look these paradigms into the same platform, blockchain and SDN, how we can combine these paradigms at the same platform. Let's start with the introduction. According to Ericsson's technical report, there has been huge global mobile data traffic, and 5G subscribers are expected to reach 4.4 billion by 2027. And we have three different contents: enhanced mobile broadband, ultra-reliable low latency, and massive machine-type communication. And 85% of them are in enhanced mobile broadband, which requires huge bandwidth with a moderate and delay latency requirement under 4 milliseconds. But the current fixed wireless access cannot handle these requirements. Therefore, the infrastructure provider should handle new equipments in order to handle these requirements. These requirements are also caused by augmented virtual reality-based smart city applications, wireless-based offices, and online educations. Fixed wireless access is also expected to offer broadband to 3 million connections projected to 2028, and newly deployed fixed wireless access, forwarding data over fixed wireless access is expected to exceed 19 GB per month per a smartphone, according to these statistics. And according to these contents, for example, enhanced mobile broadband requires huge bandwidth. Ultra-reliable low latency requires zero latency. That means in 5G and beyond, we have a few milliseconds latency. It is called zero latency. We have also massive machine-type communication. Also, it can be called as massive IoT communication. It requires also huge capacity from the infrastructure. These are served by monthly guaranteed service instead of quota service for fixed wireless access. Therefore, today we will focus on monthly guaranteed service, gigabyte or megabyte per month, instead of current quota service at a time. And due to persistent economic reasons in a pandemic, there is partial recovery instead of full recovery. The physical infrastructure needs extra expenditure in order to handle these new requirements, but we have limited resources and they cannot handle these requirements. Therefore, we need to buy a new network equipments, actually. But this is the extra operational and capex that means. We have the service provider also prefers to partial recovery instead of full recovery. Therefore, we try to use same network equipment with a software-defined way, actually. And the indispensable goal of 5G and beyond also is minimizing the risk of deployment, because the most probably the problems can be caused by network administrators, because handmade configuration has also many risks. Therefore, we try to do these configurations by dynamically. Therefore, we need software-defined networks. I will configure. I will also consider these details. And in software-defined network, we have data plane and control plane. In data plane, we have physical open flow switches. We have open flow protocol in order to communicate data and control plane. Open flow switches are actually dummy devices which takes dynamic configuration from controller. They have no brain. They take embedded rules from controller, and according to that, the flows are forwarded. And the control plane, we have SDN controllers, and SDN controller embeds flows into open flow switches by considering their configurations. But in Cisco, Huawei, or Ericsson's open flow switches in the current network, there is no deployment configuration permission, actually, in software part. Because in each open flow switch, we have software and hardware parts. In hardware parts, we have, for example, TCAMs and etc. We have hardware-based forwarding rules. We can embed it by also dynamically. But in software part, there is no configuration permission. This is the needed because of the reducing the risk of deployment. If we can dynamically develop the configuration by SDN controller, we can also handle this configuration in the software part. Thanks to that, we can both hardware and software-based open flow tables at the same platform. Instead of using fully recovery in the network, we can use also same physical equipment by actually handling these requirements. The research question is also how should we configure this switch? We can use platform as a service, infrastructure as a service, or software as a service. In the cloud network, we are actually familiar with software as a service, but in the hardware part, we have infrastructure as a service. We can dynamically configure the hardware part, but we have also software part in open flow switches in order to increase the open flow tables. We can also use it as software as a service. Therefore, I'm calling it as open flow as a service in order to serve this open flow switch by also infrastructure as a service and also software as a service in needed. Therefore, we have 5G contents at the top of plane. We have several service providers. We have one infrastructure provider at the bottom of the plane. According to that, this service provider, if they have any configuration need, they can hire my open flow switch according to some fee, actually, instead of fully recovery. Oops, sorry for that. There is also a security challenge in order to hire and use same network equipment between different service providers. We have network slicing and they have no permission in order to configure each slice. Therefore, we need network privacy. We need to also obtain standardization because each part should obtain open flow switch standardization. We have layer 2 and layer 3 standardization in open flow conformance. There is also contention between providers because there are several providers which try to use same network switch. We have also computational work in open flow switch in order to decrease this computational work because we bring extra security issues on this platform. We try to handle blockchain secured software-defined network. Instead of this, we can use centralized authority, but the centralized authority makes extra point of failure challenge. Also, we have extra computational work in each open flow switches. In order to decrease this, we try to trust computational work, and also we try to trust blockchain-based smart contracts between open flow switches and physical components. And the whole research question is, how can the service provider keep their own network sustainable? That means, they can use partial recovery by using infrastructure in a secure, cost-efficient, and confirming the standard in a fair way. In a fair way, that means content-based. We have EMBB, URLs, and MIOT or MMTC. We try to handle these requirements in a fair way also. And the contribution is sustainable fixed wire success. We have OpenFlow switches. They can serve OpenFlow switch as a service. They are configured by software-defined network controller for each service provider. We have one physical infrastructure, and they are hiring these OpenFlow switches to the service provider as a fee of OpenFlow coin fee. And finally, we can reduce operational and CapEx because of deploying data and control planes and also using partial recovery. We have also a global view in order to handle these content requirements. We have also periodic end-to-end configuration. We have end-to-end management on flows in the current OpenFlow switch, but we have no dynamic end-to-end configuration. Thanks to these infrastructure and also as a service paradigm, we can also use end-to-end configuration by software-defined controller. Basically, we can see the details. We have infrastructure provider. Actually, there are OpenFlow switches, and the same equipment can be used by different service provider. For example, we have EMBB service provider, URL and MIOT service provider. These service provider can hire same physical equipment for a time, and these smart contracts can be also stored in our blockchain. For example, the data can be service provider 1 virtually configures OpenFlow switch 1 for a OpenFlow coin fee for a such content details and also requirements, etc. We have service provider signatures and also infrastructure provider signatures in order to handle these blocks and add the blocks into our OpenFlow blockchain. I will go also detail. Here, sorry for that, before coming here, we have OpenFlow protocol in order to embed forwarding rules in OpenFlow switches. We have also netconf, or we can use restconf also, in order to configure these hardware and software parts of OpenFlow switches. Thanks to SDN controls, they can also use both protocols in order to configure and also embed forwarding rules into same components. Sustainability is proposed or defined by this formula. I have here cost per megabit per second and waiting time, which also calculated by the load in each switch. This is also statistically calculated by queuing theory by using MMCK. But the cost of megabit per second is calculated by cost of switch, OpenFlow switch, number of switch, and if we have in the conventional one, we have fuel recovery, we need to add new switch in order to handle these new requirements. But in the proposed one, we have pretty low price because we have current costs and also OpenFlow coin fees in order to handle this partial recovery. This is also pretty low price while comparing the conventional one. We have also fair content management, the monthly guaranteed service, which is also called as fee here. And let's go the details of the blockchain. We have different parts in each transaction actually. We have transaction ID, we have randomly defined or algorithmic based defined nonce value. We have data, for example, service provider 1 virtually configures OpenFlow 1 with a following OpenFlow coin fee. The service providers, controller, and also OpenFlow switch signs these data. According to, while after taking these signatures, we can also add this block into blockchain. The line actually data structure is shown here, but we can use also different one. Merkle tree or different hashes also can be used here in order to build a blockchain, but I prefer to show only line part here. The previous hash also, the hash of whole block is calculated and it is also stored as previous hash of the next block. Then we can continue the new smart contracts accordingly. And why we trust the blockchain-based security here, actually, we can decrease the computational work on OpenFlow switch because, and also in hardware-based OpenFlow switch, we have security database. In each security database, in OpenFlow switch, I mean, we can also store this copy of blockchains. And thanks to that, the miners and also validators of blockchains are here SDN controllers. The service providers, the SDN controllers of service provider can also act as a miner or validator, and thanks to that they can also earn OpenFlow coin fee, and later they can also use them in order to hire these OpenFlow switch, and their computational capability is higher than the switch. The switches only stores copy of OpenFlow chain, and also they can validate the differences between slices. And this is the details of the content-based fair scheduling in the OpenFlow switch. We have different SDN controllers at the top of, and they have transactions, actually the arrival of smart contracts by the configuration or using OpenFlow part. In the OpenFlow switch, we have different configuration and OpenFlow messages as an input. According to that, we have blockchain manager block. We have a security policy database where the OpenFlow blockchain are stored here. We have smart contract manager, which also validate these network slices. And we have at the bottom of the OpenFlow switch content manager. And we have weighted fair content scheduler in order to differentiate the content-based requirements, because EMBB needs huge bandwidth, but URLC needs zero latency, etc. In this paradigm, we have hardware and software part. The forwarding engine, if we consider quality of service or monthly guaranteed service, the URLC part other balancedly distributed to software and hardware parts. According to that, the weights can be calculated. And we try to be fair also between these different contents. And service provider adds, for example, new OpenFlow table. Here, service provider 2 adds also new OpenFlow table here in software and hardware part. And we have also public engine, which also configured by physical infrastructure provider in order to handle other traffics in the network, actually. And this is the communication diagram of the smart contracts. If a service provider takes a transaction and also sends transaction request to OpenFlow switch, it handles, it validates firstly in order to check OpenFlow table status, and also the smart contract is built. It is signed by SDN controller of service provider. It is also signed by OpenFlow switch. And this contract is also built as a blockchain by handling nonce value according to, for example, proof of work or proof of stake mechanisms. And in this paper, I'll consider proof of stake in order to be handle acceleration and also end-to-end delay requirements. And also the blockchain is stored in our OpenFlow policy-based switches. And thanks to that, I'm summarizing the cost analysis actually. We have cost per user and also cost per megabit per second. Thanks to using partial recovery of OpenFlow switch and also handle this security by blockchain, we can decrease EMBB up to $60 dollars. We can decrease URLC up to $47. We have almost 50 or almost 40% decreases in operational and CapEx expenditure. If we consider also cost per megabit per second, we also have again 30 or 40% decrease on these contents. And I tried to show also one more result, sustainability result. If we increase the user intensity, actually content-based URLC or EMBB fair rating, if we increase the intensity, the proposed one can only sustain, because after rho is increased to 0.9, we cannot handle the other paradigms. We can only show sustainability in URLC1 proposed architecture. The conventional one cannot handle these requirements. And the EMBB-based weighting, the same result can be also shown, but the sustainability is decreased while comparing to URLC one because EMBB needs also huge bandwidth requirement. Therefore, we try to lower EMBB flow than URLC while considering sustainability with same physical component. And thanks to proposed sustainable fixed virus access, we can handle while the rho is increased over 1 actually. And according to performance evaluations, we compare conventional and proposed one, and the blockchain-based open flow decreases 40% and 53% discount on cost per user. And thanks to open flow-based blockchain, the service provider offers more sustainable network. As a future work also, I'm covering the proposed software sustainable fixed virus access. This motivates the connecting services by pricing services at a transaction level. Instead of service level, instead of monthly guaranteed service, we can consider transaction level services. This will pave the way for transaction as a service on pricing strategy in whole mechanism in the network. That means the more service we provide, the more cost efficiency for us. We are also continue these details in the future work. And thanks for listening actually. If you have any question, I can handle these questions also. Teşekkür ederim.
If you have a question, we can have one question. Okay, please.
Thanks for the presentation. I would like to ask about your proof mechanism of blockchain system. You said our miners are STM controllers.
Yeah.
And in the blockchain systems, system security is proportional to the number of miners and specialty of miners. My question is, wouldn't the low number of STM controllers cause security vulnerability for the system? Because, you know, for example, blockchain or data systems have lots of miners. But your miners are STM controllers. Is there any possibility to cause security vulnerability?
Yeah, you are right. Actually, the number of providers and miner or validator is important. Each service provider can act as this role. Actually, we have also one SDN controller in also our physical infrastructure, which can be also act as a centralized authority, but we don't need this guy. But if a service provider does not prefer to hire my OpenFlow switch, it can still also act as a miner and also validator. And we try to fair distribution to be winner between service providers in order to handle this security. And they can earn as again OpenFlow coin fees, and they can transfer these OpenFlow coin fees between different paradigms. They can hire OpenFlow switches also in the later. Therefore, they prefer to be miner, also validator in this network, actually.
Okay, thank you. I have two questions, actually. First of all, is there any practical application for this now? Have you applied any real-time application to this topic? This is the first one.
Actually, I can answer it.
Yeah.
In this research, I have Python-based blockchain in order to evaluate this environment and also simulate in the MATLAB part. But we have OpenFlow switch deployment in Turkey now, which is supported TADEP, and we can handle this security on this switch. Actually, it can will be public in a few years.
That's great.
Yeah.
The second question is that applying blockchain is important, but how about drawbacks of that? Is there any increasing traffic, performance of those? It is effective or limited? Is there any limitation of those just because of adding hashes one by one?
You are right. Actually, in order to handle the transactions as a smart contract, we can consider now monthly guaranteed service. But as a future work, I try to handle as a transaction as a service. It will decrease, actually. We have many transactions. There will be threshold, actually, in my next research. How we can decrease, for example, millisecond level transactions, maybe. Also increase our network-based backbone traffic. You are right, we have a threshold here, but I'm continuing this research in order to handle this threshold.
Okay, thank you.
Thank you for all.
And let me thank to Dr. Müge for her prestigious speech, and she will remember us for future